Right now, Iceland is on fire. And I don't mean that metaphorically, I mean it literally. We're talking about massive earthquake swarms, lava fountains shooting hundreds of meters into the sky. It's volcanic activity on a truly staggering scale. But the thing is, this isn't just some random chaotic event. It's the awakening of a 1,000-year cycle, a geological rhythm that hasn't been seen since the Vikings were around.
And that brings us to the absolute core question here. What happens when the unstoppable force of a centuries-long volcanic cycle runs headfirst into the immovable object of our modern technology? Because right now, Iceland is trying to do something that sounds almost impossible. They're trying to engineer their way through a continent that is literally tearing itself apart.
So to really get what's happening, we need to rewind a little bit. How did we get to this point? Well, it all started with what you could only call a fiery awakening, a series of events that put not just Iceland, but really the whole world on notice.
When you look at this timeline, you see just how incredibly fast this all escalated. I mean, after centuries of being pretty quiet, things started with a few rumbles in 2019. But then, bang, by March 2021, you have the first eruption on this peninsula in 800 years. Then the whole system started migrating, moving southwest, until November 2023, when a massive tongue of magma forced the emergency evacuation of the entire town of Grindavik.
And if you want to understand the sheer power we're dealing with, just look at this number, 40,000. That's how many earthquakes hit the region in just a couple of weeks. These weren't little tremors either. This was the planet basically screaming that a colossal amount of pressure was building up, and the ground itself was about to rip open.
All this chaos makes you ask a really basic question. Why Iceland, right? What is it about this one little island that makes it such a geological powder keg, one of the most active spots on the entire planet? Well, let's break that down. The thing is, Iceland gets a geological 1-2 punch. First, it's sitting right on top of the Mid-Atlantic Ridge, where two massive tectonic plates are literally pulling apart. But the real kicker is that this fault line is also sitting directly over a mantle hotspot, a giant blowtorch of superheated rock coming up from deep inside the Earth. It's like taking a crack in the planet's crust and then putting it on a high-powered stove.
And the result of that geological stove is just mind-blowing. Take a look at this. Over the last 500 years, this one small island has produced 1/3 of all the lava that has erupted on the Earth's surface. A full third. That's an absolutely incredible amount of material for a country that's smaller than Ohio. But here's where the story gets really wild. This current crisis, it's not random at all. Geologists quickly figured out that what we're seeing is part of a very old, very predictable rhythmic cycle. One that has played out on this exact same landscape many, many times before. And you won't believe where they found one of the biggest clues. Not in seismic data, but in old books. They turned to the Viking sagas. The Norse, it turns out, were fantastic record keepers, and they wrote about a period they called the Reykjanes fires, describing events that sound eerily similar to what's happening today. What everyone thought was just folklore is now being used as a survival guide. And modern science absolutely confirms what the sagas were saying. By drilling down and looking at ancient layers of ash, geologists found a clear pattern. You can see it on this timeline. These long, intense eruptive periods, each one lasting for decades, separated by about 1,000 years of quiet. The cycle that kicked off in 2021, it's happening right on schedule. So here's basically how it works. For hundreds of years, the plates pull apart, stretching the Earth's crust like a rubber band. At the same time, magma is constantly pushing up from below, adding more and more pressure. And eventually, well, the rubber band just snaps. The crust fractures, and you get all these earthquakes and eruptions that will probably just keep going until all that built-up stress is gone. Okay, so the planet is doing its thing. But here's the difference between now and the Viking Age. This time, we're fighting back. And that brings us to this absolutely unprecedented attempt to engineer defenses against what is, for all intents and purposes, an unstoppable force of nature.
Iceland's Infrastructure Protection Group basically developed a military-style 4-step strategy. First, they monitor. They use satellites to watch the ground literally inflate like a balloon as magma moves around under the surface. Then, they model it, using software to predict where the lava will probably go. Next, they build these enormous walls to steer it. And finally, they react, ready to close pre-planned gaps in those walls with only about 15 minutes of warning.
And they learned really fast that not all lava is created equal. You've got the chunky, slow-moving lava, which one scientist described as geological porridge.
It just piles up, so you need giant, strong walls. But then you have the runny, fast Pahoheo lava, which is more like honey. You can't really stop it, but you can try to steer it. It just shows how incredibly adaptive they have to be.
And the scale of this whole effort is just huge. I mean, some of these new defensive walls are 24 meters high. That's like an 8-story building made of earth and rock. They had to open up entirely new quarries just to get enough material. This isn't some small side project. It's a massive national undertaking to protect things like the Svartsjö power plant, which is critical for the country.
So, what does this all mean for the future? Well, the tough truth is that this isn't a short-term crisis that's just going to go away. It's the start of a centuries-long marathon. This is the new normal, and it's going to last for generations.
So this means Iceland has to adapt for the long haul. They're already talking about burying power lines and pipelines, redesigning major roads so they can be rerouted in a hurry, even using AI to get better predictions. But it also means facing some really hard realities, like the fact that you can't save everything. You can't build a wall to protect a town like Grindavik when the ground literally splits open right down the middle of it.
And this is exactly why this story matters to everyone, not just people in Iceland. This is a real-time experiment. It's the first time in history a modern nation has tried to engineer its way through an ongoing volcanic crisis of this magnitude. The whole world is watching, because if they can make this work, it could become the blueprint for how we protect our cities from the forces of our own planet.
So that leaves us with this one final massive question. As we watch this incredible battle between human ingenuity and ancient geological power, are we actually watching the future unfold? A future where we don't just evacuate from disasters, but we actively try to build our way through them. The answer? Well, it's being written right now, in fields of cooling lava.